Hello everyone, welcome back. In the first video of the Tableau series, we took a tour of Tableau interface and we saw how to make some basic charts. In this video, we will look at some concepts, we'll see how date fields are handled in Tableau, and we'll see how to analyze data to discover insights in Tableau. We will begin with measures and dimensions. Tableau identifies each field as a dimension or a measure in the data pane, depending upon the type of data the field contains. Dimensions appear above this line in the data pane, while measures appear below this line. Dimensions contain categorical data that can be used for slicing the data to create groups, thereby affecting the level of detail in the view. Measures, on the other hand, contain numeric or quantitative data that can be measured. By default, measures are aggregated by Tableau, so when we drag a measure into the view, Tableau applies an aggregation on the pill. Region is a dimension, and when we drag and drop it in the view, Tableau shows us the individual values. In contrast to this, if we drop a measure like sales, Tableau aggregates it by default to sum. Although we can change the type of aggregation if we want, from sum to average, for example. The bottom line is that measures are always aggregated, while dimensions are shown as individual values. Do you notice that region pill is shown in blue while sales pill is in green? You might think that this is because region is a dimension and sales is a measure, but that is incorrect. This brings us to the concept of discrete versus continuous. Continuous data is data that falls in a constant sequence, while discrete means individually separate and distinct. Discrete data is countable, while continuous data is measurable, which is why most dimensions are discrete while most measures are continuous. Tableau represents data differently in the view depending on whether the field is discrete or continuous. Continuous fields are colored green and an axis is created in the view when they are added to a row or column shelf, while discrete fields are colored blue. When a discrete field is put in the row or column, a header is created in the view. Region, for example, consists of individual categories which are countable, while sales is a continuous field and hence we see the axis. Do you know that fields can be changed from discrete to continuous and from dimensions to measures and vice versa? Let us explore this using discount field. Discount is a measure with numeric values. When added to the view, Tableau aggregates it to sum because it's a measure and shows it along the axis in green as it is continuous. Let us change it to dimension. Now individual discount values are being shown without any aggregation, but they are still being shown along axis as it is continuous. If we make it discrete, the axis disappears, the pill turns blue, and the values are now shown as individual items as headers. Finally, if we change it to discrete measure, we see the total, sales displayed as discrete value without any axis. The value is being aggregated as it is still a measure. However, since it has been converted into a discrete value, the aggregated value is being shown as an individual item or an header without any axis. I hope this clears the difference between dimensions versus measures and discrete versus continuous. Let us now explore the date field in the context of what we learned just now. Date is available in the dimension section of the data pane. Let's drag and drop order date in the view. By default, it is displayed as a discrete value, which is evident from the color and the data being shown as individual items rather than the axis. This can also be seen from the context menu. Not only this, we can view date as date part, date value, or exact date. Date parts are just the individual parts of a date all by themselves. So a date of July 18th, 2000 could be broken down into individual parts. To view the date parts, use one of the options in the highlighted area. And when I use just one of those parts, example month, as a dimension in a view, then Tableau aggregates all the sales at the level of month across all years. Date values, on the other hand, are indeed the value of the date. It refers to a particular day of a particular month in a given year. The highlighted part shows different levels of date value that can be selected. Depending upon the level of detail you select, you will get a value that is truncated. If we want, in this view, we can change month from date part to month as a date value. When we do that, we see both month and the year part of the date is retained while the rest is truncated. We also see now the date are being displayed in a chronological order and they have been converted into continuous field. If we want, we can change it to a discrete field, however, like this. And now, instead of date being shown on the axis, they are being shown as an individual header items containing month and year. And finally, if you want to view the exact date with the precision it appears in the data, you can use the exact date option. By default, it is continuous and shows the date in a chronological order. How the date level is computed depends on how the date properties are configured for the data source. To configure the date properties, you go to Data Source, right-click, Date Properties, and now you see the options where you can configure it as per your needs. Moving on to calculated fields, while creating visualization or analyzing data, often we need to create new fields to discover insights. In Tableau, we can do that by creating calculated fields. Let us do a profitability analysis of our products by creating a new field called profit ratio, which shows us the profit per unit sales. To do that, we go to Analysis and create calculated field. It opens up an editor where we can type the field name and the formula, which in this case is total profit upon total sales. Our field has been created. Now we can use it in analysis. Let's begin by analyzing product-wise sales. To do that, we'll drag the product information on the row shelf and the sales information in the column shelf. Drilling it down to the product subcategory level. Next, we drop product ratio on the marks card. This view shows that tables, the one of the few highest selling items, are actually making loss. To break it down, as per the region, we'll drag the region on the view. And now we see that Eastern region is making the maximum loss on tables. Not only that, all the three regions are making loss on tables except for West, which is barely profitable. This is an example of a very simple calculation. Not only this, we can also do complex calculations if needed. That, however, is the topic of the next video. This is all we have for today. To recap, we looked at concepts like dimensions versus measures, discrete versus continuous, handling dates in Tableau, creating calculated fields, and using them for analysis. In the next video, we look at Tableau calculations in detail. That's all for now. Thanks for watching.